It was actually 5 years ago that we presented the MANRS project, believe it or not. So we've made quite a bit of progress since then, but I specifically want to just give a sort of overview of where we're at, but more importantly, present a tool that we've developed, which will help network operators get some perspective on how they're doing with respect to routing problems. But just to set the scene, there are around 71,000 autonomous systems connected to the internet. Obviously, as I'm sure most people are aware, these use a unique autonomous system number to identify themselves. But there's also around 10,000 multi-homed ASs, in other words, nets connected to 2 or more other networks, which is the sort of figure we're really interested in. You know, I'm not going to explain how the BGP system works here. It's a technical audience, but obviously BGP is used to exchange routing information, and the routers use that to build a routing table to send their traffic across the internet. Now, the main problem with BGP is that it's based entirely on unverified trust between networks, and there's no built-in validation that these updates are legitimate. So the upshot is that basically any network can announce anything, and although the regional internet registries and there's other sources of information sort of do maintain up-to-date contact information and information about number resources, there's really not a lot that stops any network or any party putting anything into these databases. So the problem is that the routing system has been under attack for pretty much since the beginning, but sort of as the internet's grown over the last few years, this has become more and more of a problem. And just to try to illustrate the sort of difficulty of the trust relationships, this is an attempted mapping of the internet by CADA. I think this is from 2 or 3 years ago. And this is really trying to show all the different relationships and how traffic flows across the internet. You sort of see in the middle there the spider's web, the tier ones, moving out to the sort of stub providers or stub operators. You know, you can't really see a lot from this, but that really does illustrate the complexity of the relationships of the global routing system. Now, there are 3 main problems that we're trying to deal with here. Again, I'm not going to go into huge depth here because I think these would be familiar to most people, most operators. But firstly, we have the route leaks where a network operator is accidentally announcing routes that it shouldn't be announcing to other providers. And this is causing network traffic to be sent in the wrong direction or through the wrong operator. And this can be problematic in a number of ways. We saw just last year a couple of big incidents. Telstra made a number of misannouncements. In fairness, they were fixed pretty quickly. And then there was a provider in Brazil that misannounced a lot of routes, which were picked up by another big tier 1 provider. That was in about July last year. And there was also another incident back in April, which got a lot of publicity. You then have the route hijacks. So this is very similar to a route leak, but this is actually more of a deliberate attempt to misadvertise a route on the global routing system. This is typically done perhaps for censorship reasons, sometimes done for traffic reconnaissance reasons. But for example, there was one back in April last year, Ross Telecom, which caused a number of outages on to a number of large cloud providers, for example, but some operators too in that particular region. And then the other third problem is IP address spoofing. So fake or false source IP addresses in packets. This can be used for attack vectors and also for distributed denial of service attacks as well. That's a very common usage of IP spoofing, which I'm guessing many of us would be familiar with. So these are all the things that we're trying to address here. Just to give an idea of the scale of the problem, this is a 6-month period last year, and this is just BGP hijacks. This isn't even suspected BGP leaks. And as you can see, there's something happening pretty much every day of the week, if not every day of the week. You can see that big spike there. That was the Ross Telecom incident in April last year. So that brings us to MANRS, or mutually assured norms for routing security. And this is really trying to bring together a number of established industry best practices to help to try to eliminate some of these most common threats to the routing system. So none of this is anything new. The routing system has been around for 30, 35 years. Well, BGP has at least. A lot of these problems are well known, and a lot of people have worked on solutions to this. But there's never really been a sort of concerted effort to try to introduce these things. So this is where MANRS comes in. So it's bringing together all of these best practices into a program. And we're hoping that network operators will adopt these actions. And if you implement them, this will reduce some of the problems that we've been seeing. So it's about collaboration between the participants and taking some shared responsibility for the internet infrastructure. So why we're doing this? So this is really, as I mentioned, about encouraging networks to implement pre-existing best practices. But we also want to help networks identify and address the problems that they have. It became pretty clear to us when we started this that networks are just simply unaware sometimes that they have these problems, and even if they know about these problems, they're not always sure how or why they're happening. So the idea is that if enough network operators implement these actions, the effects of some of the problems like route leaks and hijacks that we've seen, less damage that those can do. But we also wanted to build up a sort of track record of routing incidents, so we can sort of identify whether this problem is getting better or worse. We can identify where the worst problems are. We can identify who the real offenders are as well. And that moving towards more of a self-regulating community of responsible operators. So very brief overview of the MANRS actions. So we have 3 separate programs. The network operators program is by far the biggest of the 3, and that comprises 4 actions. So 3 of these are compulsory actions, and 1 is an optional action. So this is about implementing route filtering. That's the first action and probably the most important action. We have an action which is about ensuring contact information is kept up to date, so there's accurate and responsive contacts in the networks. Then when we do have problems, the network operators undertake to respond to those problems. And we've seen that was very effective in the case of the Telstra incident last year. And we've got a global validation action, so that's ensuring that your IP prefixes and ASs are registered in an IRR. But ideally, we would like operators to implement RPKI as well, or actually, you can implement RPKI or put your resources into an IRR. And then there's also an anti-spoofing action as well, which is currently optional. We do have a counterpart program for IXPs. I'm not going to go into this in too much depth. It's got a number of actions that are very specific to IXPs, but we very much encourage IXPs to participate in MANRS as well, because they're very key to encouraging their customers and members to implement this. And then more recently, we introduced a CDNA cloud program. So that only started last year, but we do have quite a number of the large players involved in this. And again, it has a very similar set of actions to the network operators as well. Slightly more, but very similar. Okay, so that's all very well. So that's the overview of the MANRS program. But really, we realized some time ago that we needed to have a way of actually checking whether network operators are conformant with these actions, but more importantly, helping the network operators themselves to check their conformance. As I mentioned, that when we started working on this, it was very clear that a lot of network operators just simply didn't know that they had a lot of these problems and didn't have easy ways to identify them. So this is the motivation for creating the MANRS Observatory. So this pulls on a number of different third-party data sources. So it collates together some of these sources have been around for a while. So, for example, BGP Stream, we have Jeff Houston or an APNIC's CIDR report we use. We have the CADA spoofer database. There's also the different RIR databases, the WHOIS and RIPEStats, and also their IRRs as well, counterpart IRRs. Currently using RPKI validator, although that's going to be going away in the near future, so we'll need to replace that. And there are, of course, other resources as well, like Team Cymru has a BGP Stream source as well. We have looked at that and we may use that. But what we wanted to do is to keep this within recognized, freely available data sources. So I'm going to move now to actually a live demo, and hopefully this will work. So I'm going to have to do a quick switch on the screen. And here we go. And Keith, can you see this okay?
Yes, I can.
Okay, great. So this is the MANRS Observatory. So anybody can go to this, it's publicly available. And you'll come to this top level, first level screen, which gives you a dashboard of routing conformance, depending on what you're looking at, but this is looking at the whole of the internet at the moment. So you see down these sort of circles here. These correspond to each of the MANRS actions. I did say there were 4 actions, and this shows 5 circles, but I'll come to that. So you can look at the first action, filtering. How is the internet as a whole doing with this? You've got anti-spoofing, then you've got coordination. So that's just really, it's a contact information. It's a valid contact information in the WHOIS databases. And then the last 2 are actually both action 4. So the first of those circles is IRR conformance, and the second is RPKI. So if you look at sort of the 4th circle along, generally networks are quite good at putting in their prefixes into the IRRs. As you might expect, RPKI take-up is lagging a little bit, or quite a lot actually, but it is growing, so that's a positive thing. But the only thing we can't check externally or passively is anti-spoofing. So we require the networks to run the CADA spoofer software. Those results get sent to CADA, and we pull that from their database. So only if a network has actually run that in the month concerned, we can check that. But so not most networks haven't done that, at least not in April. But yeah, that's something that we ask if networks do want to join the MANRS program. So that's the global view, but you can also look at this by other geographical region. You can look by country, you can look by UN region, sub-region, perhaps RIR region. You can look at RIR, say the right region. What you find, for example, often the figures are not particularly different. Obviously coordination, the RIPE NCC is pretty strict on putting the contact information into their databases, so that's 100% as you would expect. Obviously Europe is a bit ahead on terms of RPKI deployment as well, which is good, and it looks pretty much the same for sort of routing incidents as well. So we can also go to look at this we can look at this for individual countries. Um, luckily, the UK is big enough you can actually select it on the map. If you're Liechtenstein, which we did have to look at the other day, it's pretty hard to find, but you can enter this up here in the search. You can just type Liechtenstein or whatever you're looking for. But I can select the UK here. So now we have the UK information for the UK. Again, UK is a bit above average in terms of RPKI deployment, about the same for IRR updates, and everything else is sort of very similar to a global level. Okay, but this is not probably amazingly interesting. It's sort of a nice academic interest. But what we really want to know about is what was the information for individual networks. So we can get that, and we can look at all of the networks that are registered in the United Kingdom. This is at the moment sorted by ASN. Looks like Janet was probably the first registered network in the UK by the looks of things, which doesn't surprise me in the slightest. So certainly, this access to the individual data is by, you need to be a MANRS participant to see this. We can give access to this if you're sort of aspiring to be a MANRS participant, but by default, you actually need to be a member of the MANRS program to see the network data. Now, the thing here is that actually most of the UK networks are looking pretty good in terms of region security. So it's quite hard to find some bad examples. And I don't really want to single anybody out here, but I'm going to single someone out. I'm going to single out the big incumbent provider in the UK, not because they're bad, because they're actually pretty good for a big network. But it's a good example. So I'm going to pick this unnamed network, which you can look up the ASN and see who they are. But again, I just want to point out that some of this, not all of these incidents may actually be real root hijacks or root leaks. They may just be false positives. I think in this case they possibly are. But it just shows you what you can do in the observatory. So I'm not picking on this network here. But for example, we can look down here and we can see, so if there's been a root leak or a root hijack, this will be listed. So it looks like this network here has had a root hijack. There's a couple of hijacks there that lasted 13 days each. And this was flagged by BGP Stream, flagged up by BGP Stream. Now you can see what that prefix is, and I did look that up, and that's actually the Department of Work and Pensions in the UK. I don't know who's hijacked their prefix, well, whether this is a genuine prefix or whether they're a customer of this network or not, I don't know. I didn't look that closely, but potentially this is a root hijack, and you can identify that. So you can identify the path through the internet that's come from. So that's sort of a good indication. So you can go down and you can look at, so Bogons, you'll often see Bogons, for example. You'll often see Bogons from North America. ARIN flags administrative Bogons. So these are networks that they've lost contact with or haven't paid their bills, and then their resources get flagged as Bogons, which is a little bit of a nuisance because they're not really Bogons. But what you'll often see is sometimes you'll see private ASNs will be advertised on the internet, which they shouldn't be. They flag as Bogons as well. So you can sort of see that. If there's been spoofing, you can see that. And then coming down here, you can see this network has a number of unregistered prefixes.
Hi, Kevin. It's Portia. Just to let you know, you are 5 minutes to Q&A.
Really that. Okay. And then you'll often find that there's IPv6 prefixes don't get registered. Networks seem to forget about those. So you can see there's definitely an IPv6 prefix in there as well, and a few others too. And similarly, we can also look at what prefixes haven't had rows created for them as well. So in this particular case, there's about 100 prefixes that haven't had rows created, and this can be used to identify this as well. We can go back and look by previous months as well. So that was just for April, the information for April. But we can have a look at the history as well. So here I'm looking for the whole of the UK, but you can look at this sort of historical record as well, see whether incidents are getting better or worse for an individual network, or whether, or for a group of networks. It doesn't have to be one network you look at, you can look at a whole group of ASNs as well. So that's a very brief overview of what's possible. It's quite a powerful tool. You can dive into a lot of different, look at a lot of different things here. But in the interest of time, I'm going to now just quickly go back to PowerPoint. And okay, so I think I already discussed who can access this information. So all of the aggregated data is publicly accessible. The MANRS participants can have access to their detailed data as well, although we can create accounts for organizations that are interested in signing up to MANRS and just want to work through some of the problems that they might have, and we're quite happy to do that. Okay, so how effective has this been? Okay, so last year was a really big year for growth for this. Even though that we had all of the COVID problems and there was a huge sort of growth in the use of the internet, networks really seem to sort of spend a lot of time getting their routing in order. Not just getting their routing in order, but also signing up to this program, to the MANRS program as well. So we're currently at nearly 700 ASNs. There's 63 IXPs, and although the cloud program, CDNA cloud program just started, we already have 17 signed up to there. So that's been sort of really positive that there has been this interest and this sort of undertaking of networks to improve their routing security. Just within the UK, there's just over 2,000 ASNs that are advertised, registered in the UK, and 28 of these are actually participating in MANRS at the moment. So that's a relatively small percentage, but actually in terms of most countries, it's actually quite high. It's usually, you find it's like 0.2 or 0.3% of networks. So actually UK is doing pretty well in terms of the MANRS program. But I think the point is that most of the UK ASNs do look to be MANRS conformant. It looks like there's very few that have problems, and potentially they could all they all look pretty good in terms of MANRS conformancy. And then just in terms of the impact, okay, you have to sort of be a little bit skeptical about cause and effect, and there's as I say, lies, damn lies of statistics. But what we have seen is there has been a distinct decrease in the number of routing incidents that we've observed in the last 4 years, which does appear to be a correlation with an improvement well, particularly with the increase in the number of MANRS participants, but also as networks have been adopting better routing security measures. It isn't just the networks that are in MANRS, because a lot have been working on improving their network security as well, which haven't actually signed up to MANRS. So that's a sort of maybe a positive impact of the program. So I think I'm out of time. So I'd just like to say, if you're interested in finding out more what the requirements are, we do have some information about how to implement each of the actions. So sort of technical guide, which is actually also a right BCOP as well. So this has some community endorsement. So you can work through that. But if you're interested in signing up, then please go to the MANRS website and just fill in the form that's there. So I think that's the time, and I'll hand back over to Keith, perhaps, or Portia.
It's me, actually, Kevin. I'm Leo, and I'm going to be asking you one of the questions that came in a moment. But before I do that, I just want to ask Dinesh to pop up the poll, because that is how we'll be getting feedback on today's presentations. So we do have time for another question if anyone wants to submit one. but we have a question now from Dave Wilson, and he asks, for the MANRS presentation, is this something you see as being targeted at the NetOp eyeballs for analysis during or after an incident, or something that will feed into automation, or even something like the system team Cymru just showed off to nip things in the bud?
Okay, well, I think so the first point is that this is not a real-time system. So this is reliant on data that's a day old at least. So it's you know, essentially you're working from past data already. So it can't flag things in real time. But what it can do is, I think this is more a preventative measure, because you can sort of see where you have had problems, and you can look at that and you can identify where you have problems and what you can do to fix those problems. So I would definitely see this as more as preventative. I do think that probably it does have some use in sort of post-incident forensics as well. So for sure, yeah, I think it has some value with that on that side of things as well. And indeed, I think some networks have actually used it for that as well. There's some ones that have had some some significant incidents that have been using this. Yeah, I mean, that's a positive thing. Although, you know, we can all name some of the big offenders, they have actually shown some sort of public responsibility here, and actually we have been talking to them, and they have been using these tools to help them work through the issues that they've had.
Thank you very much, Kevin. We have time for another question if anyone would like to ask one. And if you put your hand up, you can ask the question verbally yourself. Otherwise, I just mentioned that I contacted MANRS yesterday, 2 days ago, and I got a response within an hour. So super responsive team, and that's always appreciated.
Yeah, we try. And I didn't know that you had actually, so I didn't deliberately reply within an hour, but yeah, good to know.
Okay, it looks like we don't have any more questions right now, so I'm going to hand back to Keith. Thank you very much, Kevin.